Okay, so far we learned that relationship between x and y can be graphed. Okay, so a proportional relationship between x and y. So as x increases from 0 to 1 to 2 to 3, if the y proportionally grows the same amount, 1 to 2 to 3, right, that forms a line. Okay, so we get this equation to be, well, y is equal to x. Okay, and there's some variations of that with slope and y-intercept. And we saw parabola where as x grows 1, 2, 3, 4, the y does not grow proportionally. It grows a lot faster. Initially it's 1, then it's 4, then it's 9, right? So the graph looks like this. Okay. You have to understand that the graphs are a way, okay, a visual way to understand the relationship between x and y. Okay, it's a visual representation of a relationship between x and y. Of course, we learned that as long as it passes the vertical line test, meaning for every x, there's only one y that corresponds to that x value, we call that a function. So what we're interested in now is, well, if we have the function y equals x squared, if this were to move here, move here, move here, how would the corresponding equation look like? And we have some idea about this because in grade 10, we learned the vertex form. Right? So we saw that as an example, like x minus 2 squared plus 1, this meant that the vertex was located at positive 2 and 1. So why positive 2? So if you square any number, the smallest number, if you square anything, the smallest is 0. Okay, and that smallest happens when x is equal to positive 2. And it's because of this negative 2. Because of that negative 2, x has to be positive 2 for this to turn into 0. And then it's because of that plus 1, the minimum value will not be 0, but 1. Okay, so the vertex is located at, so this will move to 2, 1 to form the same parabola. Okay, let's do one more. If it was x plus 3 minus 2, because of this plus 3, right, because of that plus 3, it moves, the minimum value will happen at negative 3. And then we have to move down twice, right, because of that minus 2. Because the minimum is, without that, the minimum will be here. But because we subtract 2, we are now here. Okay. Okay. So how about for a function like the root function? The base root function looks like this. When x is 0, y gets mapped to 0. When x grows to 1 step, square root of 1 is 1, so we're still proportional. I mean, at least from here to here it is. But the next whole number, we have to put 4 under the square root to get a value of 2. So it looks like a sideways, a half of a sideways of a parabola. How about this? Right, what if we had a square root of x minus 2? How would that look? Okay, remember here, if I did x minus 2, move to the right 2 steps. How about this? Here too, okay, the smallest value for y is when x is equal to 0. Because if you square root of 0, you get a 0. Here, the smallest value will happen when x is equal to 2 because of this minus 2. Okay, so the smallest value on this is right here. That will move to here because of the minus 2. Okay, and when you plug in 3, you get square root of 1. So the graph looks like this. So effectively, the minus 2 moved the graph right 2 steps. Okay, so we're going to go through more examples on how functions actually move left and right, up and down. So left and right movement is called horizontal translation. Up and down is called a vertical translation. Okay, we'll discuss that more with more examples.